Hi Annie.
Hi Janakiraman.
So last lecture I was looking at the power management IC in a mobile phone. I showed them the example of how the display gets switched off when you make a call. Okay.
Okay.
So we did some very rudimentary calculations to see how each IC consumes different amounts of current over time, and therefore how you calculate the total energy consumed and all that.
Right.
So of course that was all in milliamp hours, kind of numbers. But now I thought we should just jump scales. We should be looking at much larger numbers. So that brings me to an interesting, topic of discussion. This being summer in Chennai, it's always summer in Chennai.
It's always summer in Chennai. Yes.
But there are some summers which are very hot, some periods which are very hot, and your air conditioning consumption would have gone up. So how has your electricity bill been in recent times?
It's been very high.
Okay.
And it's been a big topic of discussion with my neighbors and friends.
Absolutely right. So it's expected that it's going to go up. So I thought in this discussion we should just discuss what is present in an electricity bill, right?
Yeah.
So what I've done is, since to avoid any controversy, I picked my own bill. Okay.
Okay.
So that you have it here, right? And so this is for the month of April and May, right? So this is clearly the hottest months in Chennai.
The hottest months in Chennai.
Right? And where my AC consumption would have gone up and all that. So let's just look at these numbers a little bit. I think if you were living outside the IIT campus, you would have a particular number.
That's right. Slightly the format of the bill would be slightly different.
Slightly different. It would be linked to your Aadhaar card and some things like that extra. But otherwise, I think the details here capture the essential quantities present in an electricity bill.
Yeah.
Okay. So the first thing we see is, okay, there is some meter that is attached to every house. So what is that meter, by the way?
So I have heard it being called various names, maybe power meter. Power meter is the most common way of referring to it.
Right. And so that, like meters, it counts something?
It counts something. I see that they call it units.
Okay.
Right? It counts in something called number of units. In fact, I see this even in the newspaper.
Okay.
I see people talking about, so many units of electricity, the cost is going to go up.
Okay.
It's summer, people are using many more units of electricity.
Okay, right. So that's what it says here. Current reading 52977. Previous reading was 52506. Obviously a number less than that.
Right.
And the difference between the two across 2 months, by the way, is 471 units.
Units. Actually, it says that right there.
Yes. Bi-monthly units. Right. So let's put that down first. So it says 471 units in 2 months.
Yes.
Okay. Okay. So, intuitively, I just like to first understand this unit itself, right? I mean, it is not an electrical quantity as yet.
That's right.
It's not voltage, it's not current, it's not power, right? But what should it be? I mean, could this be measured in volts, amperes, or should it be measured in power, watts, or joules, or what?
Okay.
What do you think?
See, I would think because power is something that you are giving instantaneously, because you are at any point of time you are multiplying voltage and current.
Right.
My gut feeling, you could now talk about power delivery to your home at any specific instant of time. Right. But now the bill said in fact you have written saying over 2 months. So time matters, right?
Time matters.
I would think.
Right. So I think based on our discussion on battery and charger, I think you have already ruled out the fact that we can talk about just amps or volts and stuff.
Yes.
It has to be either energy, joules, or watts.
Or watts,
right?
Correct.
So let's take an example, right? Something that we already, all of us know, right? An AC consumes lot more power than just a 40-watt bulb, right?
Yes.
So so let's say that this unit that they are measuring this bill in, right, is in watts.
In watts, okay.
What would it mean? It would mean that I have an AC which is, let's say, 1 kilowatt. Okay. And I have a bulb, right? Now let's say I use the AC only for 5 minutes in a day.
Okay.
That's all, and I turn it off. 40-watt bulb, I keep it on 24/7.
Yeah.
Okay, or I'll make it even, even more interesting. 5 minutes in a month. AC is on for 5 minutes in a month, but the bulb is on all 30 days.
All 30
24/7. Right?
Okay. Okay.
Now, if these units were in watts, right, you're going to be penalized just because you own one big AC.
One big AC.
But you don't use it.
That's right.
Right? The other guy below is using a 40-watt bulb all through the year.
That's right.
And is paying much less than you, right? So
that's right.
Like you said, power sort of represents some instantaneous, delivery, that is quantity. So it has to involve time.
It has to involve time somehow.
It has to involve time. And we already saw in the battery, we looked at milliamp hours, right?
Yes.
Or watt hours kind of numbers, right?
That's
Milliwatt hours and stuff like that. So it's going to be no different even in the
power supply.
Power supply and the electricity measurement for billing, right? It has to be some measure, right? Measure of energy.
Energy and not power.
Yeah.
Okay.
And cannot be power, right?
Yeah.
Now, we already, by the way, in an earlier lecture, we already saw that the 230 volt sine wave, right? Even though it's varying with time, we can treat this 230 volt as if it's a DC number for power analysis, right? We called it the root mean square voltage.
That's right.
Right?
That's right.
And therefore, even for this purpose, we'll not get into the that fact that that's an AC supply and it's time varying and all that. We are going to deal with about 220 to 230 volt AC, but we are going to treat it like a DC supply.
Okay.
For power analysis.
Okay.
It's okay. We already saw that this is perfectly fine, right? So now let's go and just see, let's just do a search on the internet, right?
Okay.
1 unit of electricity. People already have asked this.
Okay.
So a basic search simply says 1 unit of electricity is equal to 1 kilowatt hour.
Okay.
Okay. So let's go and put this down. So this we are now saying is equal to 1 kilowatt hour.
Okay.
Okay. And remember, because this is measured over months, we are not dealing with this in either milliwatt hour or watt hour like we did with the battery. Right? This is like big gadgets, AC and fridge and all that over a period of 2 months. So therefore, it is going to run into thousands of watt hours. So therefore, it sort of makes sense that you just scale the number by 1000 and report it as in kilowatt hour. So this dimensionally is still joules. Right?
Yeah.
It's just joules and is some energy being delivered to your unit.
That's right.
So now let's look at what this means, right? My bill said 471 for 2 months.
For 2 months.
Right? And 2 months is approximately 60 days.
Okay.
Right? So per day,
okay,
it appears like I am consuming, what is this?
About 8 units, little bit less than 8.
Exactly, 480 if I make it, it's about 8 units.
Yeah.
Right? Or to be precise, 8 kilowatt hour.
Okay.
Okay. So what I want to do now is it possible for me to estimate, first of all, from my house, the appliances that I have, I want to make sure that this number is correct. Right? Am I consuming 471 units or 8 kilowatt hours per day?
Right. So this 8 kilowatt hour means it's almost like I take one instrument which is burning 8000 watts of power and I run it for 1 hour.
1 hour.
Is that right?
Exactly. Okay. This is what we saw even in the battery.
In the battery.
Milliamp hour, we said if it draws 8 milliamps, it's like for 1 hour it will provide that 8 milliamps, right?
Right.
Okay. So similarly, exactly what you said, right? So this, I don't even know if it's high or low at this point.
Right.
Okay. So we're just going to, let's go and look at, what are the typical appliances that I would have at home first, right? So I have 2 ACs in my house, but I run only one of them because we are all, going to be in the same room. So 1 AC Okay. And this comes in, various flavors, 1 ton, 1.5 ton and all.
That's right.
So I have gone and already fished out my 1 ton Daikin AC.
Okay.
Okay. And what does this say? It says it's connected to 230 volts.
Okay.
And consumes 940 watts of power.
Okay.
Okay, nearly 1 kilowatt.
Yeah. Let's just round out the numbers.
Yeah,
It's a
we are
lot
not
easier.
worried about the last number, right? These decimals. So 1 kilowatt of power is what the AC consumes, right? Then the next biggest item is the fridge.
Right.
Right. So what is the fridge like, right? So let go and look at this. I think I had was it here? No, I had it. Yeah, I think it's about maybe 165 liter fridge
Okay.
wattage.
Okay.
Okay, and I think I have a 220 watt. Okay, how many watts? Okay, this is annual power consumption. So there is one issue the moment we talk about fridges and ACs and all that, refrigerators and ACs. Are they running always?
Well, no, they are not, because actually when I'm sitting near the fridge, suddenly I hear a tick sound and then I hear the grrr sound from the
running.
fridge, something running on the fridge.
I think that's called a compressor or something.
It's a compressor.
Right?
That's
compressor that runs, it cools it down. So there is something that has measured and found out that it's cooled enough. So it shuts off.
It shuts off.
Right. So likewise with your AC.
I've seen the same thing with my AC as well.
Right. If you set it to 16 degrees centigrade, obviously it will keep trying to cool it until the room, at least the point where the sensor is reaches 16 degrees centigrade, and that's never going to happen because you'll always open the door, go out, come in. It's always going to be a problem. If you set it at 30 or something like that, it's essentially going to get there quickly and it will cut off. So it will be very power efficient if you set it to maybe 27 to 30 or something like that.
Yeah.
Okay, but in any case, the wattage doesn't change. It either runs at that wattage or it doesn't run. So it's like that display IC that switched off. Right?
Yes.
It just went off after some time. Right. So there is an on and then so there is a duty cycle. Right, in which this appliance is going to run.
Right.
Okay. So therefore, okay. So now the fridge, it says a 200 liter annual power consumption, 720 kilowatt hours. And 1 second, let's try to get just the wattage number because this is, I think, taking care of the, the duty cycle and all that.
Yes.
What is the wattage of this? Oh, 230 watt.
230 watts.
Right?
There you go.
So this is 230 watt. Okay. Let's round it off as usual, 250.
Let's say 250 watts.
50 watt. And in kilowatts, it's going to be 0.25 kilowatt. Okay.
Yeah.
Now, what else? Then I have lots of tube lights.
Tube lights, yes.
Right. And the tube light is what? Do you know what the wattage is?
Probably about 35, 40 watts, let us say.
Yeah, about 40 watts.
Yeah.
Right, and in kilowatts, it's what, 0.04
Yes.
kilowatts. Okay. And then I have now.
Maybe a fan?
I have 3 fans that run.
Okay.
Okay. Okay, I'll put it.
Maybe we'll just write it for 1 fan.
Exactly, and then we'll multiply it,
We'll
right?
multiply.
Fan for how many? So what is the wattage of a fan? I think that I had put down somewhere here, not this. So do you know what the wattage is?
Probably maybe 80 watts, something like that.
80 watts,
Yeah.
right? Okay.
Yeah.
80 watts, right? 0.08 kilowatt. Okay. Now, of course, as you know, there's like we discussed, the duty cycle is very different for each of these appliances.
That's right. That's
so
right.
first we'll put down, okay, how many numbers there are.
Yes.
Right. So this is the appliance. This is the count. Okay, I have I have 1 AC, 1 fridge, maybe 4 tube lights, okay, and a fan. So how much? And the fan, I
Maybe
have
3 of them.
3. Yeah, okay. And how much time?
Yes.
Because that's also important, right? So, just going back here, I had 8 kilowatt hour per day.
That's right, per day.
Per day.
Yes.
Okay. So, I am trying to account for 8 kilowatt hours of usage, right? Now, my AC in peak summer, we don't use it a lot and we keep it near 27, 30 or something.
Okay.
So, it runs for about, I would say, 6 hours.
6 hours, okay.
6 hours, some 3 hours in the night, 3 hours in the afternoon or something like that. Okay. After that, we turn it off and we just, the fridge of course runs all 24 hours, right? I want to write this in hours. Okay. Tube light is again 24 hours, no, maybe evenings, right? 6, maybe 6 hours or 8 hours,
yeah.
right? And fan is of course 24 hours in Chennai,
okay.
right? So, yeah. So, this is what we have now. So, what is the kilowatt hour usage here? This is what we are going to now look at. The AC, like you said, 1 kilowatt, right?
Yes.
It's running for 6 hours, so it straight away gives you 6 kilowatt hours.
Okay.
Okay. And the fridge is like 0.25 kilowatt, but for 24 hours. So, this is what?
About 6.
About 6.
24 into 0.25.
But this is where the duty cycle comes in,
yes.
right? What you mentioned.
Yes.
It is not going to be 6 kilowatt hours.
Yes, of course.
It will be some scale number. So, let's assume that duty cycle, what's the reasonable number?
Maybe it turns on maybe every a few times an hour, shall we say?
A few times an hour. So, how would you measure this if you wanted to do it? Suppose you want to get a very gross estimate.
Yes.
Sitting at home, how do you do this?
Good question. So, maybe I would, without any instruments?
No instruments.
No instruments.
Maybe a watch.
Maybe just a watch?
Yeah.
I'll just hear when the compressor turns on, turns off.
Yeah.
And then based on that, I'll be able to
right? And then, so you will get maybe, so maybe I'll add that number here, right?
Yes.
I'll add a duty cycle.
Okay.
Right? And this one in the 6 hours, because it's running for a very short period, I think it would be close to 90%, because by the time it gets and then it's 30, we switch it off.
Yeah.
Right? So, I would say 0.9.
Yeah.
Okay.
Okay.
This guy is, like you said, 25%?
Yeah, let's say 25%.
Yeah. Okay.
Yeah.
And this duty cycle is, what is this? Tube light? Tube light is 100%.
100%.
Right?
Tube light and fan will also be 100%.
100%. So, it's just you switch it on and it keeps running. That's all, right? So, therefore, the
so in fact, now the AC would become, since the duty cycle is 0.9,
yes,
it would become 5.4.
5.4, right? Exactly. So, the AC power, where can I'll just write it here actually.
Yeah.
Actual power.
Yes.
Right? So, 9, right?
5.4, I think, right?
5.4,
6 are 54,
correct.
yes.
5.4 kilowatt hour.
Yes.
So, this is 24 times
So, this will be 24 times 0.25. In kilowatt hours, it would be basically 6 kilowatt hour.
Yes.
But then 1/4, so this would be 6 in kilowatt hours, but 1/4 of that, so 1.5. So, maybe 1.5
kilowatt
hours would be the actual use.
Actual usage, right?
Yes.
And what about the tube lights?
This would be 24 times 0.04, so that is about 0.96.
0.96, 1 kilowatt hour?
1 kilowatt hour.
Right? And then the fan?
Yes. And then the fan is
72
times 8.
Yeah.
So, about
let's say 0.1 this is.
Yeah, let's say this is 0.1.
Yeah.
So, it's about 7.2.
7.2.
Is that right? No.
No, it doesn't seem right.
That doesn't seem right.
24 hours. No, this is not, this is 0.1.
Yes.
Right? So, this is 7.2 hours.
Correct.
Right?
Correct.
Into 0.1, that is.
Correct.
Seems like.
But you have assumed that the fan is running for 24 hours?
Maybe not in all the rooms.
Maybe not in all the rooms?
Yeah. So, maybe that would be a little less, right?
Yes.
I would say on average.
Let us say
on average 3 fans, I would say 6 hours.
6 hours, right? Maybe it's not running for all 24 hours.
Exactly. So,
right?
18, so about
So
18 into 0.1.
about 1.8
1.8.
kilowatt hours.
Okay, yeah. Okay, so this seems to be the average usage per day.
Per
right?
day.
Okay.
Yeah.
So if you add all this, you get what? 5.4, 6.9, 7.9, 8.9, and maybe 9.8 or something.
9.8 or something.
9.8 kilowatt hour. Right?
That's not too far off.
That's not very far off, given that the bill seems to suggest I'm using 8 kilowatt hour per day.
I'm sure you must be going on travel.
Exactly.
A few times a month.
Exactly, right? You go elsewhere, you don't use it on a day, and
that's right.
Some of these duty cycles also may not be very accurate, right?
Correct.
But clearly what this is telling you is, there is, the AC which seems to be the bulk usage.
I think that makes sense.
Yeah.
Because nowadays when I go, I see the AC running full blast everywhere I go.
Exactly.
I would not be surprised at all.
Exactly,
that the AC
right?
is the number one. In fact, there have been a few times when my house electricity bill has been too high, or I suspected it too high. The electricity board person came and he looked at the AC and said, most likely you must be running this AC for a long time. This must be the reason.
Okay, okay. So clearly,
yeah.
And you could also have a very bad AC if your filter is not good.
That's
it will
right.
be doing a lot more work. So all of that matters. So
yes,
it's important to keep this guy under check if
yes.
you want to reduce your electricity bill, right? So keep your AC in great condition. That's the general message, right?
Yes.
And of course, the other things add up, especially lights and fans. To some small extent, they do add up, right? But the fridge seems to be the next thing. In any case, this was just a back of the envelope calculation to make sure that it is commensurate with our usage, right? But now, we saw this number, right? We saw the we saw the number of units, 471.
Mm-hmm.
But then there's another thing called billing amount, which is what I pay and which is what actually matters, right?
Of course.
So,
at the end of the day, nobody cares about the number of units,
right?
You only care
so
about the money.
if you want to, if you were trying to control the usage of power, because actually if you have hundreds and thousands of ACs running in the city, what do you think will happen to the power grid?
So I would imagine that, I'm hoping that the power grid is able to deliver that much power, that much energy, right? If not, it will be in trouble.
It will be in trouble, right? So let's say you have a battery which is like some 5 volt and some few milliamp hours, whatever, it can deliver certain current, right? This 5 volt it's not an ideal battery, like we discussed, right? Where you can deliver any amount of current for 5 volt. There is a certain current limit. Beyond that, voltage drops. Right? Essentially. So that's what will happen in a power grid as well.
You know something? I have actually noticed it. Till a few years ago, when I would turn on the AC, I would see a momentary dimming of the lights. I don't know if you have seen it.
Exactly.
Right?
Exactly.
For a half a second, it will just dim and then come back up to normal.
And then come back because you're drawing too much.
I'm drawing too much current. There is something called a starting current, is what I have heard.
Exactly.
So it draws too much power instantaneously, it dims and then it settles down.
Exactly, right? So essentially, as a power, delivering company, you need to sort of incentivize reducing power consumption, right?
That's right.
So one thing that you can do is to look at this average usage, and then decide that the billing need not be linear, right?
That's
one
right.
thing we always assume is linearity. That is, if I consumed 471 into 2, 940 units, right? You think my bill should just go up by the same factor, right? It should just become 4,500. But no, it can become 10,000. It can become 12,000.
Of course.
Right? So that is exactly what happens even with your billing, right? So there is of the number of units, there will be some free units.
Yes.
Right? Sort of to help people who are not able to afford it. Beyond that, it gets charged at some X rupees per unit.
Yes, per unit. And then once it goes beyond what a normal family would use,
exactly,
it goes up tremendously.
You can even make this 3x rupees per unit.
Yes.
Right. So this is like a slab, right? So this could be maybe first 100 units or something like that. It could differ from city to city, state to state, right? Next, maybe 1,000 units.
1,000 units and so on.
Correct. Right. And beyond 1000 units, you had it.
Correct.
Right? Your electricity bill is going to shoot through the roof. So you better be aware, or at least try to keep it within this
Yes.
bar, right?
That's right.
Then you are sort of safe and you can ensure that your bill is under control.
Makes sense. You know, this reminds me, I have heard in some Western countries, they actually get billed depending on what time of the day they use electricity.
Oh, okay.
I have not heard about it in India,
Right.
but in some parts of the world, they bill them based on, so if you use it at peak hours.
Oh, so the peak hours is like what, morning 9 to 5 or
Maybe
something
morning
like
9
that?
to 5 or something,
Okay.
because people are working everywhere, large machinery is working,
Okay.
already the grid is delivering a lot of power.
Lot of power, right?
So, if you are also drawing power at the same time when everybody else is trying to draw, they want to disincentivize that.
Wow.
So, they make it more expensive.
This is not, so you can even bill non-uniformly through the day.
Through the day as well,
right?
yes.
So, oh wow. And it could also be on Sundays, for example.
Exactly, it could be cheaper.
It could be cheaper, it could be
right.
whatever. So, I think the key takeaway from there is, if you want to corroborate your numbers, look at the units.
That's right.
Right? Because that is linear. More AC, you run it for 8 hours, you will end up using sort of proportionally more number of units, right?
Yeah.
It's very difficult to, tie this to the exact amount, because you should know what the details are in terms of the billing non-linearities.
That's right.
Right?
That's right.
Okay, good. I think hopefully with this, people should be able to appreciate the electricity bill and understand the components, and hopefully also reduce
Their power consumption
at home.
That's right.
Right? Thank you.
Thank you.